directly to the central processing unit rather than having to go through the basic interpreter, which of course takes time as the program is running.
Of course, equally, you could have written it in BASIC and used a compiler which would compile it once and for all into machine code and then run that, and you'd have had a similar sort of speed up.
Yes, we could have done that.
Excellent. Well, thank you, Ian. Well, the owl only used 11 pictures, and to make it more realistic on cartoon animation, an artist would draw all the positions in between. Of course, it's possible to use a computer to do this, even between quite unrelated pictures.
That technique was actually called in-betweening. Let me show you on our micro. I'm going to load up a program here, and I've done a drawing of an egg, and I'm going to turn that into a chick. Let's start it off. Now, what the computer is doing, it's working out all the different points on the egg, how they compare with the same points on the chick, and then moving them across from one to the other. And again, on this program, we're using the colour switching idea so that you don't actually see the drawing taking place. We're nearly there now. There we are, and it's finished.
Great, I like your chickie and also like your owl. How are you getting these drawings into the computer?
Well, I'm not much of an artist, but let me show you how it's done.
Ah, you're copying.
Well, here's a very inexpensive piece of equipment. All we've got is a flat board and an arm here. At the end of the arm, there's a little stylus that tells me where I'm actually drawing. At the elbow joint and at the pivot here, there's a couple of variable resistances, and the values from those are fed into the computer, and with the right bit of software, we can then calculate where the stylus is, both in the vertical position and in the horizontal. So let's just have a go at drawing a bit of the owl. There's his back and a bit of the tail. I took a bit more care when I drew the previous one, but I think you can get the idea. And here's a bit of a wing, and round, and so on. There you can see it's the beginnings of the owl.
That's terrific.
Well, that's a nice, inexpensive piece of equipment. Let's go to the other end of the scale. Here we've got something rather more sophisticated. In fact, it costs about the same as the computer. Video camera, if you'd like to stand in front of it and let me take your photograph. Now, in fact, what's happening, the image from the video camera is going through into this magic box of tricks, and the points of brightness in the picture are being transformed into numbers, and then they're being sent down into the computer. And here comes your picture. Well, the first thing we ought to do is to set a threshold level, which means anything above a certain value is going to be white, and everything below it is going to be black. Now let's enlarge the picture. Here it comes, and you can see all the various dots, black and white dots, and there we are. It's not a bad picture of you at all.
That's not bad at all. Of course, once it's in the computer, you could transmit it across the world, and people could see my image on other computers, I guess, and you could use it for all sorts of... It's rather a lot of fun, isn't it?
Oh, yes, you're just really, at that point, you're limited by your imagination.
Well, for now, thanks a lot, Ian. Well, you probably aren't going to be using your micro to create the Son of Tron, but one of the most important uses of computer graphics is in design. And over here, we have a computer-aided design system that runs on an ordinary micro. It's controlled by this joystick here. There are actually quite a number of controls in this. You can move it in any direction. You can actually turn this, and this will enable me to select a larger or smaller part of the screen. And there are 3 control buttons here, which will enable me to select various things on the menu. Well, we've got a house here, and we can look at it in much more detail by positioning this cursor on and either zooming in or out onto a section we're going to deal with. This one is going to be the dining room, so we'll zoom in on that, and it'll redraw it in a much larger scale. Well, currently, the popular method of designing the interior of a house is to take pre-printed sheets like this and transfer these onto the actual drawing of the house. And you can get baths and so on and total furnishings. The disadvantage is that you're limited to what's on the sheet. You can run out of them, and you're limited to the actual designs there. We have those similar designs stored inside the computer. And, of course, you can extend these to any number that you want. We'll pick them out and have a look at some. And I'm going to actually position some furnishings in this drawing. Here at the top we've got a sofa there, two-seater there, and chair and tables here, table and chairs there. So we can position the cursor over that and select it. And it'll go back to my plan of my dining room, and I can position that there in my dining room, like that. And it will immediately draw it in position. And I could very quickly position another one alongside it if I wanted to have a number of them. We can then go back to the main plan of the house and have a look at that, and we simply select page, and we're back at the plan of the house, and we can see those actually there in the dining room itself, and there they are being drawn. But of course what we're seeing on the screen is much less than the actual detail that's held in the computer itself, and we can see this by zooming in. And I select zoom, and this is the part that I think is absolutely magic. And we can position the cursor there very tightly on that window. We can see there's something curious in that window, and we simply zoom in on it. And it's immediately redrawn, and we get a close-up of the window, and there in the window is a globe. And it's actually a map of the world. And that gives a fair amount of detail, but I might say that I'd like to look even closer at that, and I can position this cursor right in there, if I can get it in, right there over where I think England is. I'll position it over England, and it should then draw England. Of course, all the detail is held inside the machine itself, and there's England. Now, I actually happen to have a cottage up in North Wales, somewhere up there, and if I position the cursor carefully over it, maybe I can actually see if it's still there. And there's the Clane Peninsula, and there indeed is the cottage. And what is even more incredible, I can still keep going and have a look in that dormer window up there. With a bit of luck, I might even find that there's a globe in the window, and indeed there is, but this time it's in the other window. It looks as if I could go on zooming in forever if I wanted to. But actually I'm not zooming in, I'm just going through various levels of information. And actually it's quite important to do that, because we can print out what we've got on the screen in much greater detail than we can actually show. Well, this is a real application for microcomputer graphics, and there are hundreds of these installed and in use in drawing offices throughout the country. It's cheap and it's easy to use. Now, it may look complicated to design a house, but it's nothing like as difficult as designing something we all take for granted. The craft of making shoes really hasn't changed much over hundreds of years. Essentially, a flat piece of leather is stretched round a mould or a last, and the sole is either nailed or glued on the bottom. But the problem